All right, so now we're moving into chapter 3, which goes into stoichiometry and chemical equations and formulas and how they relate. Okay, so just when thinking about chemical equations, chemical reactions, one of the fundamental principles is the law of conservation of mass. The idea of what we start with is what we end with. So with this quote, we may lay it down as an incontestable axiom that in all the operations of art and nature, nothing is created. An equal amount of matter exists both before and after the experiment. Upon this principle, the whole art of performing chemical experiments depends. Okay, so then let's talk about chemical equations. So chemical equations are representations of what occurs in a chemical reaction. So when we write formulas, or in this case, when we show like models interacting with each other, they are representations of actual chemical reactions. So when we write a chemical equation, there's a variety of pieces or information that is given in a chemical reaction. So on the left side of the arrow, we always have our reactants, and then on the right side, we have our products. Okay, so the things we start with are reactants, the things we end with are products. The states of the matter are also represented by small symbols in parentheses. G standing for gases, S standing for solids. Sometimes instead of S, you'll see a C, and that stands for crystal, but that basically means solid. It's the same thing. It just depends on, and sometimes older textbooks or older examples will use C instead of an S. Other states might be an L for liquid, and as well as you could have an AQ standing for aqueous or dissolved in solution. Next, you also have coefficients, and these are inserted in a chemical equation to balance the reaction so that you have exactly the same amount on one side as you do on the other side of number of atoms. So when we write the formula for a compound, we use subscripts, and that indicates how many atoms within the molecule or within the compound. When it comes to using coefficients, we use coefficients to say how the number of molecules that are present. So when we go to balance a chemical equation, we do not change the subscripts. We always leave the subscripts the same. We add coefficients to balance the number of atoms on one side or the other of the equation. All right, we're going to review some of the types of chemical reactions. Went over these in first year chemistry as well. So first type of reaction is a combination reaction. In this type of reaction, two or more substances react to form one product. So things combining together. So one way that I describe it is less complex things coming together to create more complex things. So an example here with the picture above as well is magnesium metal combining with oxygen to form magnesium oxide. Another example is nitrogen coming together with hydrogen to make ammonia, which is a very important chemical reaction for the fertilizer industry and for agriculture, industrial agriculture. And then another one of liquid bromine combining with propane to form that compound. Then decomposition, you take more complex compounds and break them down into less complex things. So the definition there being one substance breaks down into two or more substances. And we'll look at a couple examples. The example here is of, at least in the image one, is of water being decomposed into oxygen gas and hydrogen gas separately. But there's a variety of compounds or reactions that we do that are decomposition reactions. Combustion reactions, now these are generally rapid reactions that produce a flame, and for combustion reactions, when they react with oxygen, especially with hydrocarbons, your products are always going to be carbon dioxide and water, no matter what. And when you think of a combustion reaction, we'll look at some of these examples here. and identify the theme. So looking at combustion reactions, the combination or compounds combining with oxygen to make products is kind of the one of the standard kind of definitions of a combustion reaction. And with hydrocarbons, that's probably the most common way that we interact with combustion reactions is hydrocarbons combining with oxygen to form different products, usually carbon dioxide and water. And that's it for the day. And we will see you tomorrow.